So now we want to come up with the inverse sine, inverse cosine, and inverse tangent function. I'm specifically going to walk through the inverse sine function in more depth. Then we'll do the inverse cosine and the inverse tangent real quickly. So first of all, we're going to draw the sketch of the sine function. We know sine goes through 0, 0, has a max of 1 and a minimum of -1. And if I were to look at some key points right here, we've got the point pi over 2 comma 1 as being a max, pi 0 as being a 0, 3 pi over 2 -1 as being a minimum, 2 pi comma 0 as a 0, and of course the value 0. And remember from what we talked about before that the area from 0 to this pi over 2, this portion here indicates the first quadrant. And you can see here the graph is above the x-axis, indicating that sine is positive in the first quadrant. From pi over 2 to pi, that 90 to 180 degrees indicates the second quadrant. And we said sine was positive in the second quadrant. So that piece of the hump represents the second quadrant. Pi to 3 pi over 2 represents the third quadrant, and we know sine is negative in the third quadrant. And then 3 pi over 2 to 2 pi is the fourth quadrant. So right here represents the first quadrant, second quadrant, third quadrant, fourth quadrant. And this graph is cyclic, so that the next hump up is going to represent the first quadrant, second quadrant, third quadrant, and so forth. And coming from the other side, it's the fourth quadrant, third quadrant, the second quadrant, and the first quadrant. Now the issue with the sine function when we're looking at the inverse is if I draw a horizontal line through this, I can see my inverse will not be a function. So I want to find a way to limit my sine inverse so that I do have a function. And there's a couple things we're going to do to restrict the function so that my graph is a function. The first thing is it's going to contain x equals 0. The second thing is you want as much positive x's as possible. Without failing for a function. So we're going to go to the right as far as we can as long as we pass the horizontal line test. Then once we are done with everything to the right, we'll look at stuff to the left. But we don't want to go to the left until we look at the right. The final piece then is no asymptote hopping. And we see that specifically with the tangent. So there's going to be a small part of our segment of the sine graph that's going to produce the inverse function. So if I take my sine graph once again, I'm just going to take a very small segment. We know right here is going to be at pi over 2. We know there is going to be pi, 3 pi over 2. And when the graph crosses the x-axis again, it will be 2 pi. And we know that the distance from 0 to pi over 2 represents the first quadrant. Pi over 2 to pi represents the second quadrant. Pi to 3 pi over 2 is the third quadrant. And then 3 pi over 2 to 2 pi is the fourth quadrant. So we're going to start with the point 0. And I'm going to continue to work to the right until I fail the vertical line test. Until I fail the horizontal line test, because I want this graph to be a function. So starting with 0, I'm going to head to the right until I would fail the horizontal line test. You can see at that point, once I pass pi over 2, I'm going to start coming back down, which would fail the horizontal line test, because then if I drew a line through here, it would cross here and there. So I know that in order for my inverse to be a function, I've got to limit myself from 0 to pi over 2. I'm going to do the same thing going in the other direction. Keep going along until I fail for the horizontal line test a second time. Right here, if I were to draw a horizontal line, I would fail if those red ticks were to continue to the left. So I've got to limit my graph to right here is negative pi over 2, and over there is pi over 2. So the domain and range of the segment, the domain is negative pi over 2 and pi over 2. The range is negative 1 to 1. So for the sine inverse function, sine inverse of x, or as we're going to say, the arcsine of x, the domain is going to become the range, and the range is going to become the domain. So the domain is going to go from -1 to 1, and the range will go from -π/2 to π/2. So what this graph is going to look like is this little segment. That right there is going to be the sine inverse of x, or the arcsine of x. As I said, the inverse sine of the domain is going to be -1 to 1. The range is going to be -π/2 to π/2. So here is going to be the point 1, there's -1, up here is π/2, and then down here would be -π/2. So when we're talking specifically about the sine inverse function, we're going to be talking about the first quadrant and the fourth quadrant. You can see right here from 0 to π/2, this is the first quadrant area. Here from 0 to -π/2, that would be the fourth quadrant. So my sine inverse, I draw it like this usually as the quick reference, indicates that sine inverse is going to be defined on quadrants 1 and 4.